Unit 5, Section 14.4 Worked Examples. Consider the apportionment of 60 fax machines for a law firm. The apportionment using Hamilton's method is shown in the table below. Does the Alabama paradox occur using Hamilton's method if the number of fax machines is increased from 60 to 61? Remember, the Alabama paradox occurs when an increase in the total number of items to be apportioned results in the loss of an item for a group. So the first thing we want to do is complete the new apportionment method for offices A, B, C, and D using a standard divisor rounded to 2 decimal places. So we've got 61 fax machines now to be allocated among the 5 offices where there's a total of 3,214 employees. So I went ahead and calculated the standard divisor. I took 3214 and divided by 61, and I got 52.69. And then I went ahead and I divided each of the office number of employees by that standard divisor, and you can see those numbers down here listed as the standard quota. And then for Hamilton's method, remember we round down, which is shown in the next row here for the lower quota, right here. And then we check the total, and we have 59, so we've got actually 2 more to allocate. And where are they going to go? They're going to go to the offices with the largest decimal portion on their standard quota, and those 2 offices are D and E. They have the largest right here, 0.79 and 0.66, the largest decimal portion, and we're up to 61. All right, so let's go back and see. By allocating, having another fax machine to allocate, did anybody lose? Any of the offices lose anything? So here's the originals up here, right up here. And we notice that nobody lost anything, and in fact, Office E gained 1, but none of the remaining offices lost anything. So the answer here is no. The Alabama paradox did not occur because none of the offices lost a fax machine, and in fact, Office E was the one that gained the additional fax machine. The college with 5 divisions has funds for 54 internships. The student population for each division is shown in the table below. Apportion the internships using Hamilton's method. Okay, so for Hamilton's method, we have 54 internships, 5,400 populations, so the standard divisor is 100. I went ahead down here and I calculated the standard quota. I rounded down and on the next row, and I came up with a total of 52, but I had 2 additional internships to allocate, and they're going to go to the divisions with the largest decimals, which is going to be right here, E and B. And now the population changed in 1 year. It went up by 54 students, and we see that some of the divisions grew, some of them stayed the same. So we're going to go ahead and we're going to do the allocation again, this using the same steps for Hamilton's method. And you can see my calculations in the table down here below. And so we notice that what happened here, Division A stayed the same. Division B, right here, actually lost a seat from where it was before. I'm sorry, an internship. And E gained 1. And so what we want to look at is what was the change in the population growth on those 2. They both went up, but we noticed that B went up just a small amount. It went from 1532 to 1533, which is an increase of 0.07%. And Division E went from 1087 to 1140, and we calculate that as a percent change. It's 4.9%. So what happened here, the division that grew the most gained a seat, and the one that lost a seat would actually grow at a lower rate. So the correct answer here is going to be, did the paradox occur? Well, let's take a look what the paradox says. The population paradox occurs when a group loses items to another group, even though that first group's population grew at a faster rate. So although B lost a seat to E, its population was growing at a slower rate. So therefore, the correct answer here is going to be A. The population paradox did not occur because Division E, which gained an internship, grew faster than Division B, which was the division that lost the internship. A company has employees in countries A and B. The number of employees in each group is shown in the table below. There are 46 managers to be apportioned between the 2 groups. So first we're going to apportion by Hamilton's method, and our standard divisor, 4,600 divided by 46 managers is 100. So I figured out the standard quota here. I rounded down. Hamilton's allocation is shown here. For the lower quotas, I had 1 left over, so I'm going to go ahead and I'm going to put that into B because it has the larger decimal. So you can see the Hamilton allocations there. Now suppose the additional employees in country C with the number of employees shown in the table below are added with 7 new managers. So now instead of 46, I now have 53 managers with a total employees of 5322. And we want to go ahead and apportion using Hamilton's method. So if you see here, my standard divisor now is 100.42. I went ahead and I did my allocations down here. I did my standard quota, I rounded down. I see I've got one additional manager to allocate, and it's going to go to A because A had the largest decimal, 0.41. And so here's my allocation. Now let's take a look at the new stock states paradox. It occurs when the addition of a new group and additional items to be apportioned reduces the apportionment of another group. And so let's take a look. What happened here? So if we look back up here and we look down at the new allocation, we notice that B actually lost a manager. And so therefore, the new states paradox did occur. Okay, so we added C, but B lost a manager. So even though C came in with additional managers, it resulted in country B losing one of the managers. So the new states paradox did occur.